I should be recording, hopefully. Having a few technical issues and such, so I have to, have to be careful how I make a video. Apparently, I have a little trouble with the GPU's temperature. OBS was crashing on me, but this should work okay, and it's running at a much more reasonable temperature. But anyway, so just letting you know. No, there's no real solution. I have to test it somewhere or other. Might as well test it making a video. Anyway, so there's been can't find a physics protagonist of any kind, anybody to discuss or debate physics. They want to debate my personal life and other things. They're just people making up all these silly stories and all these lies. Somebody's saying I strangled 2 cats. Completely. Where do they even get this crap from? Where do they get these stories they make up? Where do they get the facts? I don't know, the fodder, the material to make up these stories. I obviously know because I lived my life that I didn't strangle 2 cats. But anyway, just too silly. So anyway, that's all they want to do is make up fake lie stories, and then I have to sit there and go through all the trouble to defend myself against the silly lies, which I'm just not going to do anymore because I've already done a bunch of it and it's a waste of time. So anyway, so it's just stuck with nobody able to articulate physics arguments. And that's unfortunate. The physics can't find a defender who can stay on the subject. Who actually knows the subject. Yeah, even that. And even though I'm offering, $2,000 for a notable physicist to take the time to make a counter argument, to just play one of these arguments. So I'll go switch to photons for today, just to change of pace. But I really don't like switching because to me the kinetic energy subject is it's a glaringly bad science. So I found another circumstance where they just make crap up. So there was a mathematician who is cited as being the guy responsible for putting the 1/2 in the mv squared, and they actually write in an article describing it how he debated this with Huygens. Huygens died 100 years before this guy was born. He obviously couldn't have debated Huygens, and so you're just like, they have such glaring nonsense, even in the history they've written. You're just like, why are people defending this bad science? Can't they just admit, oh yeah, there's a lot of really sloppy, not very good, not very well argued, not very well evidenced physics? And instead they just won't even concede that. They won't even concede that their argument could be so much better if they had evidence. That they would really like to be able to show me evidence. They can't even concede that. Which is, again, it goes to the character of the human organism, and that is the fault lies, not within the stars, but within the character of the human organism. Way too many humans just don't care about the truth. That's the truth. So, anyway, they really just don't like science. Even though they call themselves scientists or science defense, they really don't like science. Because science is you follow the facts. It's not you force the facts. And there's every evidence that most of the conclusions physics has drawn regarding an elemental universe, they're forcing the facts. They're not following the facts. Anyway, so that speech made me tired. So I think I'll take a little break and I'll be back. So yes, temperature staying stable. Good. Alright, so I guess we'll start by just explaining, that all of this falls into place if you sort of get this 2 plus 2 plus 2 physics idea. That there's two elemental forces. There's not, so they say electric field and magnetic field. It's really a positive field and a negative field, a proton field and an electron field. That is, there's two kinds of little bits of energy moving the speed of light. So that's what they have in common, is the force bits always move the speed of light, and when they're free and when they're pushing matter, they move some lesser speed, and that explains gravity, as I've pointed out. But you really need the two elemental, two things that are fundamentally different to cause the inverse reaction for protons and electrons. So protons and electrons are they're the elemental material bits, and the elemental little force bits, okay, you can just imagine they're much smaller, are actually have a character, they have properties, okay, that make them inverse. That is, the electron force will push an electron and the proton force will push, so we'll put a little x in that one and put an x in this one, so you get the idea. The x force will push the x object, the O force will push the O object, and the inverse happens. When an O force hits the wrong polarity, it essentially, we could just say, goes straight through. It doesn't, but I'm not going through all the procedures. And likewise here, so there's no pushing. So there's one force that pushes, there's another force that doesn't push. But anyway, with that relatively simple interaction, you can understand it all. So there's two fields, okay, but they're not magnet and electric, they're proton and electron. There's two elemental matter bits. There's the positive charge and the negative charge, the proton and the electron, and there's just two interactions. There is, I hit you, okay, and you move, and I hit you, okay, and the force is just deflected. So, well, can't see the deflection arrow. I could just put it that way. So that's all there is. And when you understand that in the context of understanding photons, then you can understand what happens in the creation of a photon. So let me just go to that simple part. So a photon is a word for a composite object. Photons are not elemental. They're made of a pattern of force, okay, and the pattern is a frequency, a distance of nothing between somethings, okay. So that's a photon, is a frequency, just how this is blue light, this is red light kind of idea. And yes, you can have many of these, and have lots of potential photons. Alright, so, and the point is, so it's not a wave in a field or any of that kind of stuff, and all that's simply really happening is electrons are actually hit by force, they are moved, and they go this way, and then because they're in fields of this energy, the energy has it's a circumstance, because there's a proton over here and there's another electron over here. There's a certain field that's going to be reflected to everything, and so that field is going to say go back the other way. And what happens when an electron goes this way, it's pushing, okay, it's reflecting the field tighter, and when it goes back, when it goes that way, what it's doing to this other side is doing exactly the opposite. It's not reflecting anymore, so everything that was going this way isn't reflecting as much, so you get less of a reflection back this way, so you get a bigger, wider, you get dead spaces. So the direction, when I move this chalk, the direction forward of the chalk is creating a higher frequency. The direction that the chalk left, is creating a lower frequency, okay, more dead space, less reflections. And so it's basically blue and red shift, but blue and red shift are really not byproducts. They're the elemental function. They're The electron and the proton, the electron anyway, is constantly doing this kind of stuff, and in constantly doing that, it's constantly creating more dense force, a field that has more elements in it, and a field that has less elements in it because there's no reflections. So if I move this chalk away from you very, very fast, near the speed of light, it becomes invisible because nothing can reflect off of it. Nothing can catch it to bounce off of it. So that kind of a simple principle, I think, makes photons much easier to understand as composite objects, and not as what they think they are, some sort of bizarre DNA snaky thing traveling through space. They're not doing any of that. And they're not a single object. Photon is not some sort of object. Photon is a sequence of events. Photons take time to be resolved, to be created, and to create electricity on a surface. No single electron ever creates a photon. It can only create one element of the photon, one piece. That kind of thing.
This video is intended to provide a concise version of my counter theory, my counter model, my counter argument to the conventional interpretation of basic experiments like the double slit experiment in explaining
it's a pretty old video because I actually was doing the two camera thing.
How light behaves and how the mechanics of the universe function, and why the conventional theory is not very well founded, is not supported by the evidence. The evidence, in fact, basically confirms that theirs is the wrong answer.
Yes, there's certain facts that have been over so many times, but the idea is that light has a known polarization. It has a shape as it travels through space, a photon. And the truth is that shape indicates quite obviously that a single electron can't possibly be interacting with a photon, because the polarization of the photon, the shape, is perhaps 1,000,000 times bigger than an electron. The space the photon is occupying is very, very large compared to the size of an electron. And so there's no way an electron's activity could create something of that huge size.
If analyzed fairly and with some kind of effort to find the truth, rather than to sell a story of reality.
So yes, they all do the same comparisons. They go through this two slit, single slit, multiple slit. They come up with these different mathematics, and all of it can be shown that it's all based on some very wrong assumptions about reasonable comparison between water, waves, and say light. And those comparisons all fall apart in different circumstances where there isn't any parallel. The analogy is not a good analogy. And it's certainly not anything as an explicit statement that it's just like. It's not just like at all.
So, in brief, the conventional theory is that a single source of light encounters a slit or two slits, that the light does in fact.
So, this is where it's even the mechanics of it, you can see the flaw in it. So I played the Schrodinger video, and that one's basically arguing that there are variables in the world that cause these effects, that there is no randomness created out of nothing. And so here you have this simple experiment, the double slit experiment or the single slit experiment, and they don't even understand it as clearly having obvious variables. The obvious variable is the surfaces. I mean, it's right there in front of them, so to speak, and they don't pay any attention to the surfaces, and understanding that the fate of a photon that travels next to the surface is going to be likely different than the fate of a photon that travels in between, the furthest it can from the two surfaces. And that simple understanding is completely consistent with the outcome. That the rules are completely obvious in the sense that the more you narrow the surfaces, the more you close the aperture, the more light spreads. Well, that's because the odds of a photon being near a surface are increased as you narrow the aperture as you bring the surfaces, create less and less area inside the aperture. The more likely it is the photon's going to have to interact with the surface, and it's the surfaces that are causing the diffraction, that is the reflection, deflection of the light. The photon, the pieces of the photon are being broken by the surface, sent in different directions, and what you're doing is recombining pieces to create a new photon at the surface. So you put photons in with pattern, and the pattern is scattered, and then you make new photons out of the scattered pattern.
At these points, that's the mathematical fact.
So again, the obvious thing is to call it, the single slit is really the two surface experiment. The double slit is the four surface experiment. If you understood it as that's what works. The math that actually works counts those as surfaces, and those surfaces equate to producing the mathematics, the geometry for path length differences and all of that, and it's perfectly consistent that the surfaces are creating all of the pattern. Light that doesn't go by a surface just goes straight through and doesn't do anything, doesn't make any patterns. The light has to hit the surfaces to make a new photon, and there has to be enough light for there to be action at both surfaces for you to recreate a photon. So there's no such thing as sending a single photon through a slit and then saying you received the same photon somewhere, because it can't really happen that way. And again, their experiments demonstrate that the experiments aren't what they say they are. They make claims about what the results are showing, but their claims can't be demonstrated by a well-done experiment. It can only be done by poorly done experiments like the Veritasium one, which I've referenced many times.
A disturbance at 95% maybe of the light does go straight through, and that some percentage creates what are called fringes, and this creates a pattern, an on-off pattern, the simplest pattern in the universe.
Right, and again, so it's just the wider you make the slit, the less pattern you're going to get. Okay, it's going to be visible, and it's going to be at these little notches are going to be so close together that you're not going to be able to see it. And the narrower you make the slit, the wider everything becomes, because you increase the amount of scatter. You increase the angles at which the scatter takes place. And but that's all it is. It's only the scattered photons that are going to create the pattern.
This is to perplex us and force us to believe that things that seem quite discrete, that travel very straight paths, land in very small areas of surfaces, we are to believe that going through the slit meant it creates a copy of itself that somehow interferes with that copy of itself in some superimposed position of all the possible paths.
So this is their theory, that a single thing goes in, it interacts with both surfaces, so to speak, and then it is sent into two different places by the interaction. And no, none of that has to happen. None of that's necessary. It's all just mumbo jumbo. It's all made up. It's a model, and it's overtly got flaws in it. I mean, the idea of superposition, the idea of creating some sort of new elemental universal function where you can make copies of things, imaginary copies, and that the copies can interact in some special universe and then they resolve back into a single object again. I mean, it's a whole wooey theory, of not intuitively sensible mechanics, and there's no evidence for it, in the sense that the experiments can be explained with a simple explanation. If I do this experiment with radar or radio waves, it can be clearly demonstrated that the two waves don't need to interact with each other. I can put a signal here and a signal here, and I could just move the receiver in between, and I can find points where there's jamming and then no jamming and then jamming and then no jamming of the signals. It's the perfectly reasonable expectation that there would be such a circumstance. And in that diagram, there's no capacity for the waves to interfere with each other. They can't cancel and double up or whatever they can't do any interfering. So it's clearly not interference. It's just scatter.
And it chooses to land in some location, and it's all very mysterious, very wooey, very not very reasonable. I'm sorry. The simple fact is
and Feynman's explanation is even simplerly wooey, in the sense he just says the universe plays dice, so somehow when a photon goes through a slit, it just randomizes. So it doesn't matter whether it goes right next to the slit, goes right through the middle, it doesn't matter where it goes through. It, for no good reason, decides to go off in some silly angle and land at one discrete location. And it won't land at these other locations. But he doesn't really believe in interference is causing it. It's just random probabilities.
The truth is that in all the mathematics, whether it's a double slit or a single slit, if I make a double slit, I just change the number of point sources. The mathematics that works has 4 point sources, clearly indicating.
So it's in their own math, the acknowledgement that the only thing that matters is the surfaces. That they're where you start to draw your two lines, and you say which line is a full wavelength longer than the other line, and there is a spot I'm likely to recreate a photon because I've recreated the frequency. And in places where the frequencies don't match are going to be places where I can't resolve a photon because it has the wrong frequency. Just like jamming a radio. If I send two radio signals in phase, competing with each other, with two different signals on them, well, then you can, your radio will receive both and make noise. But if I send them out of phase, your radio won't be able to receive either signal. It'll fail to be able to resolve either one because it won't be able to find it won't be able to find the frequency it won't be able to tell which one to cling to as a phase. It can't see the lower frequencies in the mixture created, so the noise just consumes the signal, essentially. And that's how you jam a radio.
The surfaces are everything to the experiment. And that can be understood because the surfaces are basically a definition of a distance. The distance, the widest distance and the shortest distance between two surfaces, indicating possible vectors where one could expect to accomplish the task of bringing these lines together with.
So I'm drawing the double slit there, so there's 4 vectors, and it's when the 4 vectors are all in phase, you get a photon. When only 2 of them are in phase, you don't get a photon, not enough energy.
A wavelength of distance difference. Now again, this video is intended for people who are going to make a counter argument and know something about the physics, so I shouldn't have to explain path length differences and wavelength differences. But the simple truth is the pattern is
in phase and out of phase. So phase is still a concept when you use a particle theory of frequency. Phase still is a reality. You don't need this to have phase. All you need is something with a period, something with a time between events, and then you can say that timing can be in phase or out of phase.
Fundamentally just created by measuring those distances. So if it's a single slit, I just measure this distance. It's 2 point sources. I just divide how many wavelengths fit inside of there, and that'll tell me exactly how many of these nodes I'm going to get on a equidistant line. It'll tell me exactly how many will end up on this surface.
Right, and the easy way to do that, to understand that, is to understand if I take the 2 point sources and made them straight lines. I could try drawing. It's always dangerous, I think, but we'll try it. Yeah, that worked. So if I make them straight lines, and then I take the other point from here and make this a straight line, you can see that I can see exactly how different in length the 2 lines are. And as I go around, they'll become equal at this point, but that's going to be a fake equality. We'll get to that probably in the middle. But you're going to understand that all you're going to really do is rotate the notches here onto this other line, as I move this way around the curve, I'm just going to get to the point where the halfway mark. And anyway, so the notches are essentially just going to be places where you're saying, what's the difference? When did I add to this line a full distance equal to the wavelength of the light? So every time you add a full distance that's the wavelength of the light to one line by moving on this curve, that's a place where you have an in phase between the 2 points. So you can just easily understand that the distance between the slits, between the surface, is going to just tell you exactly how many nodes on this 180-degree arc it's possible to create, how many places they can be in phase. No one who's ever analyzed the double slit experiment that I've ever seen, that I've ever been able to find, has been able to point out that simple fact. That's where the math comes from. That's why the distance between the surfaces is in the math, is because it's telling you exactly how many potential points there are for a path length difference.
I'll know that the longest path length difference between the two lines is going to be here at 90 degrees. That's where the two lines have the biggest difference. And that difference is going to be the exact difference, okay? So if there's 14.4 wavelengths, if you divide lambda into the distance and you get a non-whole number, that remainder is telling you something. If it was 0.5, it's going to be telling you that you at this starting point at 90 degrees is going to be out of phase. Destructive interference by your rhetoric.
So, so there's no guarantee that the 90-degree point is going to be an on or an off. It can be, in between on and off, or it can be one or the other. So if it's a 0.5, it's going to be an off. If it's a 0.7, then it's going to be starting to be an on. Okay, if it's a 0, then it's going to be an on. And it's going to be that simple to just move along this arc and hit the places where there's going to be the possibility of the two sources creating something that looks in phase. That is, the element, the force bit, is exactly the right distance behind. So you sent in two photons that are going parallel to each other. And at one surface, one of them is now lagging a full wavelength behind. So this one hits and then this one hits, and it's recreating the frequency. So you're using composite elements of photons. You send photons in. The photons you send in are now going to be reordered. Their frequency is now, like the one that was in the first position is going to be matched with one that's going to have it in the sixth position or some other position because of the path length difference. And you're just recreating the same frequency, and you're hitting the same location, even though they came from they came from different places. They're hitting the same space, and now they're going to hit the same space with the same frequency because they're in phase.
What I would call it would be just absence of reconstruction, that the phase is broken, it's the wrong phase, the signal has essentially been jammed, and you won't receive it. I can't see the 90 degrees, but 90 degrees.
So you'd still receive it as energy. So all the spots that are dark, okay, doesn't mean energy didn't hit them. They're still getting hot. So if they use temperature, for example, they could probably find out that there isn't any difference in how much temperature is being caused at all these different locations, that the real energy is still hitting. And so in the microwave, for example, there's still microwaves hitting the object, and they're still hitting with the same number of them. So the absolute amount of energy, the amount of little bits hitting something, is still the same. And so the heat portion of the event will be the same. If they could do some decent thermal photography or whatnot at this kind of micro level, then they could see that the pattern is exclusive and narrow, in the sense that it's just about resolving photons. It's not about resolving the energy. So there's no such thing as photon plus photon equals nothing. There's still something hitting the surfaces.
All right. If I made a string just tied a string onto these two things and moved the string with notches on it, with the notches of this wavelength here. When I get to this top, I'll end up with half the notches on one string, half the notches on the other string. And actually, if I did have a 0.5 remainder, half of 14.5 would be 7.25. So here, at a point where I have constructive, because they're both equidistant, the fact is they're not. Okay, the fact is that the notches won't line up.
So I won't be in phase is the point. Okay, now I'm guaranteed inside. So there's another point to recognize, is that when you're doing this scattering thing, you're scattering both ways. You're scattering out, but you're also scattering in. All right, and so there's, in that little tiny distance of 1 millimeter, there is a point where the two lines would be the same length, but it's inside of 1 millimeter. It's a tiny amount of light that actually gets to that location in that condition, and the real pattern is going to be obligated to be created by what you started with. So if you started with a remainder, that is, you have a distance between the slits that is not a whole number, then you're already not a whole number or a clean half of a wavelength, which would be a clear off. Then there's no option that the center has to be consistent with the 90-degree reality. You can't change the distances. It's a fixed system. So it's just an illusion when they do the math saying that this is the same as all the other scatter. That's where they're making a critical error, because this part where they converge and meet in the center is again a millimeter of distance or less. It's not the pattern that most of the photons are creating.
So even though I'm going to have a false center there, and the trick is that is a false. In all the other comparisons, you're comparing two lines that are moving in the same direction, and only in this case inside this tiny millimeter of distance, inside the difference of the slit, which is 1.5 of a millimeter actually, is this little occurrence going to take place. It's going to take place in a tiny piece of space, and the real pattern starts here and here.
The real nodes of where there's going to be in phase. So these two can blend right into each other. And so this explains why in the single slit experiment, the fact is the center bright is more than twice as large. And it is because the two nodes are so close to each other that they're blending into one. And so you can make them see, if they did the experiment more and more carefully, they could probably actually measure that difference. That center bright does get a little bit bigger and a little bit smaller depending on where these nodes start. How much of a remainder you have will tell me how much distance there is between them. So there can be 0 distance between the two nodes, or there can be up to 0.5 distance between the two nodes. And depending on how much distance there is, it will tell you what the total size of that node is. Now, I've noticed that when you look at different single slit experiments and try to measure how big that center bright is, that it does fluctuate. Like in one experiment, it'll look like it's 3 nodes, and in another experiment, it'll just look like it's 2. So it's another giveaway that they have the wrong answer. Their theory doesn't explain it at all. It has no explanation for why the center bright is twice or more the size of the other fringes. It doesn't provide any explanation.
And this just fills in the blank. The size of the laser, essentially, the spread of the laser beam going right through the middle, fills in this difference. And so that's why the center maxima is twice as big.
So you have to understand, a lot of photons go right through the slit, hit the center, and so that part, by the spread of the laser even, just fills it in. So you don't see that they're two separate nodes next to each other, because all the light that goes straight through that doesn't interact with the surfaces, that's just blotting it out.
A little bit more than twice in most cases. Then the rest of the nodes is because it's actually a fake. It's really two separate nodes two separate nodes that started at the right distances, where this is a straight line, the shortest distance for this line, less than the shortest distance for that one, obviously. And that's
that would be one wavelength different line. Okay, so, but anyway, continuing. That would be the first node from the center. So it's one wavelength of difference between the path lengths.
Where the node actually started, and because it started with a 0.5 down here, you can understand it's probably starting with a 0.5 at that end, and then just start drawing your nodes. So they've implied that this is an infinite pattern, which it certainly is not.
So more stuff about the fact that they just don't acknowledge that first their own distance. They have a distance in the math. There's no, I really shouldn't have to draw all this stuff. So I've done so many videos on this. But they'll just do this. They'll say there's the two slits, and they'll say this. They'll call this A as a variable. Let's just say the distance between the two surfaces, and then they'll have a thing they'll call M or L. It doesn't matter, and it's just the distance to the target. And the fact is that when they're going to make these comparisons to these other locations, right? When they're going to say, well, what about this location and this location? The math obviously is telling them they have to keep L the same. So it has to be, this radius has to stay the same. It can't get, L can't get longer. So you have to understand that the pattern has to be viewed. The math is telling you what's the pattern on this curved line. The math isn't telling you what's the pattern on this flat surface. The pattern is on this curved line. That's what the math is telling you, where it'll be on this curved line. That's why they're never very specific. That's why they never do the experiment and do accurate measurements, because they're not that accurate. Because this projection on a flat screen is distorting the pattern. It's making these nodes larger than these nodes. It's distorting it quite a bit. And the real pattern is right here on this curved surface. And so obviously there's no infinity on a curved surface. We don't have an infinity problem. Here we have an infinity problem, right? I mean, you can't get away from the infinity thing. I just make this line longer and longer and longer, and we go forever, have an infinite number of angles. But obviously here there's no infinite number of angles, right? All you got is the 180 degrees of this half of the sphere. So that's all you've got is 180 degrees. You don't have an infinite number of degrees. So you can't split the last degree into an infinite number of movements. So that's what the flat surface implies. So if they just got, if they just conceded, obviously the math is the one radius, the L number is one number, every L has to be the same. If they just conceded that point, then all of that infinite stuff goes away. Because you're not shining it on an infinite surface anymore. You're shining it on a finite surface. Huge difference in understanding what the actual world you're trying to describe and model. Huge. And they've just completely, they illogically hadn't conceded to that. Hundreds of years of playing with this experiment, and yet they never even figured out that if they're going to teach the subject, they have to teach it correctly, consistent with their own math says. That L doesn't change. You don't get to change the distance to the target. The distance to the target always has to be the same, and it has to be an arc.
Specific number of nodes, and the number of nodes, the number of fringes, will be completely dictated by how many wavelengths fit between the distances. So if I made a double slit experiment instead of a single slit, you can understand that the nodes, the surfaces, there'd be four surfaces now. So the single slit is really the two surface experiment, two sources of scatter, two sources, and this is really the four surface experiment. And all you're really doing is saying these two outside surfaces, a lot of wavelengths fit inside of them. That means small nodes.
So that one's really another huge intuitive breakthrough, is understanding that you're just saying, where's the maximum difference between surfaces? Because that's the only possibility. Those are your only lines. Your only lines come from these points, and the only way these lines get longer or shorter is based on the distance between them. So obviously there's going to be two sources that are going to be very far apart and two sources that are going to be very close to each other. And that difference okay, you can understand is that if they're very far apart, that means lots of wavelengths of difference fit between them. So that means you're going to create lots of bars, and that means the bars are going to be closer together and smaller. And obviously where the two surfaces are close to each other, that is this one and this one versus this one and this one, those two, only a small number of wavelengths fit between them, so the bars have to be very big because there's less of them. And these all have to fit on here. So if the number's 5, well then there's only 5 bars on this whole surface. If the number is 15, then there's 15 bars, and they're going to be sized proportional to the number there are. And it's a huge upgrade in understanding the experiment. It's just a,
These two interior surfaces have a short distance. That means they're going to create the envelope, the big pattern. And where you can line up 3 or 4 of these vectors, where you're in phase of these 4 sources, that's where you get a bright. There is no destructive interference.
So you're really just matching the two patterns. The narrow distances is creating the big pattern. The close distance is creating the small pattern. And the fact is, where the two patterns overlap is where you get a bright. And where one of them's out of phase, like in the big pattern, is going to create those weird little empty spots in the double slit pattern. The envelope pattern is creating that. The big, close to each other surfaces, those two sources are the ones creating that big pattern, and the break in that big pattern causes a break in the small pattern because there aren't enough photons. There's not enough bits being sent there to reconstruct enough photons for you to see any pattern. So you need all 4 sources to be throwing pieces. And if only 2 sources are throwing pieces, you're not going to see the pattern. But if you get all 4 sources, you'll see the pattern.
There's been no real experiment done where they ever showed any light spot getting dark. That is, if I covered one of the, like I opened the slit and a certain amount of light hits the surface. No experiment has ever shown that if I open the slit, more light hits someplace. Like someplace that was dark, someplace that was light gets dark. There's no experiment showing that. So that's a fallacy, and the other fallacy is the detector.
So, these are all, you go just through the list of all the claims they make for experiments, and they're not really supported by any evidence. And the only experiments you'll find have clear flaws in them where they contrive the answer. Again, like the Veritasium experiment where you turn the photodetector all the way up to its highest detecting sensitivity. And which obligates the experiment to be done much quicker because of the number of noise photons you're creating. So it's exactly the opposite of what you want to be doing. You want to, if you want to get single photons, you want to be sending the least amount of energy over the longest amount of period of time to spread the energy out as much as you can to say, okay, it can only be coming in this very little tiny amounts. And anything you do to force the experiment to have to happen in a shorter amount of time is going to increase the likelihood that you have more than one photon in the experiment at any one time. Clear flaws in logic, in being fair to the evidence, in reporting the evidence correctly. It's just really bad physics, really bad science. All right, take a little break. Temperature's up to 86. It's over, once it gets over 100 is where it gets dicey. Alright, I'm back. I play a little bit more, but the essential points have been made. It's scatter at the surfaces. The surfaces are the hidden variable. They're the thing creating the phenomenon. At the surfaces, the photons are being, depending on what happens at the surface, the photon, the little element of the photon can go this way, or an element can go that way. Every element will go its own way. It's just being scattered. And then all of those little bits are scattered onto the surface, and the surface is just going to interpret whether or not they're in phase or out of phase when they arrive. So the pieces will just be reconstructed. So all you have is reconstruction and non-reconstruction. You don't have interference and constructive and destructive interference. You have either reconstruction or no reconstruction of a photon.
For an electron, or a photon especially, There's no passive way to ever detect a photon. It would be theoretical nonsense. And even if you could build such a detector, the odds are you couldn't fit it in the experiment because it's got to be so tiny.
So that's a whole nother subject that I didn't go on, I guess, very much about it. But I mean, there's a whole branch of physics that claims, like Feynman, that these detector experiments were actually done, and that there's actually some evidence, and there's no such evidence. There's no such thing as photon detection. It just doesn't happen. You only can detect photons by allowing them to create electricity in an atomic structure. That's the only way you can detect a photon. It has to hit atoms, and it has to create electricity in the atoms.
So those are just nonsense stories, part of the propaganda. What makes this work, what makes particles work even better, is understanding what light is. Just like any other radio signal or any other photonic signal, it's basically antenna dependent. So we know that the longer your wavelength, the wider your frequency, the bigger your frequency, the taller your antenna can be. So the more time you have to run energy up the antenna to create your signal.
So this is probably a superfluous, not necessary to the subject kind of argument, but the idea is to understand how it happens on an atomic level. And on an atomic level, what's happening is you're moving electrons in a bunch of different atoms when you send electricity through. And as you move those electrons, you're moving them out or you're moving them in. And so you're creating either a spot where there's more energy being reflected or less energy being reflected depending on which way the electron's going. So when the electron's going this way, it's creating more reflections that way. When it's going this way, the opposite way, it's creating less reflections that way. And the opposite is happening on the other side. So for every yin, there's a yang to the photon. So for every time you make a photon in one direction, that is, you make the elements of a photon a pattern, you're creating a pattern in the opposite direction also, which is perfectly consistent with what they've found about many experiments demonstrating that photons are created in pairs and that the pairs are opposite. The photon coming out of this end is going to be exactly the opposite phase of the photon coming out of this way, exactly 1/2 out of phase. The dead spot's going this way, the hot spot's going that way, the dead spot's going this way, the hot spot, it's always going to be 90 degrees out of phase, I guess is how they'd say that. So the point is, when electricity goes through a wire, that's how you're creating the little electrons going out and going back in again. But anyway, going out is the part that we're focused on, creating the piece of the Morse code, the dot. And then you have the empty nothing spot, and then you have a dot, and then a nothing spot. All right, dashes and dashes, I don't want to get it. It's not exactly Morse code, because obviously you're not sending two kinds of dot. Anyway, so you can just understand that if you have a very slow frequency, you have a lot of time, you have a very long wavelength, then you have a lot of time before your next signal, before the next blip, 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 blip. So when those are coming at a very long distance between them, that means you have a lot of time to send a signal, electrical signal, up a wire. But if you have a short distance and a wide frequency, that's not going to work. Or if you have a long distance and a high frequency, because you can't get up the antenna without the next signal saying you're supposed to be going this way, and it's still working on doing the first this way, so it's going to mess up the signal. So there's a comparison between understanding that. So what you're really saying is photons are created by very short antennas, very a tiny a little 1,000 atoms. That's an antenna for a photon. And then you get to microwaves, you're at 3 centimeters. You get to radio waves, you're at 5 or 10 centimeters. The distance between the ons is getting bigger and bigger, and as the distance gets bigger, it's really just telling you how far electricity can travel in that distance, and how far it can travel will tell you how long your antenna can be.
And the polarization of that light will be that signal will basically be antenna polarization. The theory is that this goes right down to microwaves with a 3 centimeter antenna.
So the idea is that the atoms on the surface, the electricity moves in a certain direction. It creates polarization in that direction. But obviously we don't see electricity in a wire, and we don't know that it's probably going in all kinds of directions. And so it's creating photons with all kinds of polarization. They're coming out in all kinds of lines dependent on which way the electricity traveled through the atomic structure.
Because that's the only speed, at 3 centimeters at the speed of light, that's as far as you can get before you have to have the next wave, and the next wave, and the next wave. The signal is stopping and starting.
So I'm using the word wave, and that just is saying that we're just talking about a period between events. So the event of going this way versus the event of going that way.
Before it can get any further up the antenna. That's why the rest of the antenna is superfluous and useless. It's because you don't have enough time to send energy up the longer antenna. So frequency is controlling in both directions, and that's essentially polarization. And the truth is that the atoms of a surface are also an antenna. And the truth is that there's a correlation between the frequency of light, that is the distance between the events of creating a photon. So I'm arguing that a photon is made out of corpuscles, but it's not one corpuscle. You don't have a...
So that's why different materials create photons of different frequencies. The atoms are closer to each other, so the amount of time it takes to get to travel 1,000 atoms. For an electron to hop between 1,000 atoms, that distance changes based on the material. That's why every material has specific frequencies of light that it produces, is because of the time it takes to hop from one atom to the next. Is it basically telling you what the frequency of the light, this motion will be, the distance between the electrons being pushed. So that the distance between the atoms essentially tells you what the distance between the events that create the elements of the photon. So the frequency will be completely proportional to the speed at which an electron push can be passed from atom to atom. Yeah.
500 megahertz corpuscle. You don't have a 500 nanometer distance between, of a size of a photon. Photons aren't 500 nanometers big.
So a photon isn't an object, it isn't a ball. It's a sequence of events. And the sequence is really just the exchange of electron perturbation. Okay, an electron is moved in an atom, then it's moved in the next atom, then it's moved in the next atom, it's moved in the next atom, and each time it moves, it creates a little field. Okay, it pushes, it reflects more light to the rest of the universe in that direction.
The frequency is 500 nanometers. That is,
it reflects all at once. It takes if I move my hand really quickly towards you, it's collecting the photons at these different locations and compressing them into a smaller amount of space. So it's taking little bits of energy that was far apart, and it's making all of that little bits in a smaller amount of space. And that's basically compression and expansion of the universal field. It's not the magnetic field or the electric field. It's the field of energy in the universe.
The period between, at the speed of light of the photon. So the photon is made of quanta, clumps of energy, clumps of momentum at a frequency. And that would be quite consistent with what you're allowed to say with waves. We understand that if we're going to make a wave theory, the waves aren't one wave. We understand that it's wave, then wave, then wave. And that's the path length difference.
So I'm trying to just make it understood that some of the facts they have are correct. Okay, frequency is correct, wavelength, these are correct notions. It's just that they're understood wrong to be understood as waves when they're really not waves. They're a bunch of individual, discrete bits of momentum that are traveling in patterns, but they're not in any way. They're all independent. They're not tied to each other. You don't move one and then move all of them. This isn't a medium in any way.
The photon can arrive at one side of the surface travel a longer distance, show up at a secondary time to recreate the wave function. That the wave isn't something that happens instantaneously, that the wave happens over a period of time. The same would be true for...
So a photon is an event, again, key word, key difference from what they teach. Photons don't just spontaneously poof. They're a sequence of events. So when they're created, it takes a sequence of events, an electron moving from atom to atom, moving out from atom to atom. And it likewise, once received, it has to be a receiving of a number of events that create an electric current in a group of atoms. So it requires more than one atom to receive a photon. You can't receive a photon with one atom. You can't just stick one atom out in space and say, there, I'm going to detect photons with it, because one atom can't make electricity.
Or particle theory, it would be made of wavelets.
And it's too small to collect the polarization of the light. You're really just collecting the polarization. You're collecting, stuff that's going to hit your surface. And one piece is going to hit here, and then the next asteroid will hit here, the next asteroid will hit here, and the next asteroid will hit here. So there's a sequence of events. Hit here, the energy is moving inside the atoms, and then you hit it again. So now you're making it more energy, and then you hit it again, and you're making it more energy, and then you hit it again, and you're making it more energy. So it's an additive process that creates the event that will be known as electricity, which is you've pushed on the atoms. And finally, that last atom you pushed, you're pushing it fast enough. You're pushing the electron fast enough to kick it out of the atom. And now you have electricity. Now you've created charge in the atomic structure. And by creating charge, that is too many free electrons, you've created electrical potential. So the electrical potential is the photon is made out of elements. And the elements are hitting in sequence and magnifying an event. They're pushing once, and then pushing twice, and then pushing 3 times, and then pushing 4 times on the same electron. You could argue it's not really the same electron, but the same energy of an electron moving from one atom to another. And they're giving that electron more energy each time they push it again. That's a photon. So a photon is an event. The event takes time. It's a sequence of events.
Of clumps, particles. And the key is that the fact is when it's created in an atoms, in a crystal of metal or some other crystal, most all photons are created by crystals, that the energy actually has to travel through the material. The photon is essentially created by moving an electron quickly. When the electron moves quickly, it takes all the force that was between...
So I could have drawn this a little better in the sense I could have pointed, well, I probably do, but, I could have shown that it starts here, and then this one here, and then this one here, and then this one here in terms of events. And so that's the polarization. The polarization is this line being created where an event is going to happen,
and the new location, and essentially collects all that force, collects all of it, and sends it all at once. So it sends a clump of energy. It could be 5 of these quanta, it could be 50 of these quanta. It doesn't really matter. And then the next atom that fires an electron, that pushes an electron, does the same thing. So these move the speed of light away, and then another clump, is created, and they move the speed of light. And then another clump is created, and they move the speed of light. And so what you end up with is clumps, at a period, all right, created by different atoms. And so you could think of it, if you're just going to draw them as single pieces of quanta, the understanding would be as polarization is essentially just the fact that this distance is proportional to this distance, that is the frequency, and that the bits of the photon are out of alignment within that polar.
So they're moving parallel to each other, just in different space. And when they hit a surface, that means they're going to hit it, and then they're going to hit it exactly the certain amount of distance away, they're going to hit again, and then a certain amount of distance away, they're going to hit again, and a certain amount of distance away, they're going to hit again. And all you're really saying is if they're hitting a surface where that resonant frequency is compatible, then that's going to amplify the energy and create a new event of electricity. Alright, that's probably enough. So I did all right. I mean, the first 10 minutes had a lot of elements in it, and I obviously added another 10 almost, and so, maybe we'll do that sometime. But anyway, enough of exposure just to the fact that, this physics is so underdeveloped. It's so immature, undetailed. It's so not very rigorous, however you want to describe it, but I mean, just obvious defects in their description. Feynman doesn't draw the curved line, okay? Lewin doesn't draw the curved line. When it's in their math, they're math whores. They know this radius is the same radius. They know when they're doing their math for these different positions, the L never changes. It's the same L number. Well, the L number's here. The L number's here. The L number's here. The L number isn't out here. This is an L. This distance out here is an L. I mean, it's obvious defects where they're not even being true to their sacred math. And then the math formula that actually works is actually counting all the sources. So the double slit experiment, when they do the right math, is the 4-surface experiment. I mean, that obvious fact, the fact that that's the math that gets the right answer. Okay, Young's shallow analysis doesn't get the right answer. Young's shallow math doesn't get right answers. It's just a proven fact. Well, it's a provable fact. Okay, you can't use his math and get the right answer for the double slit experiment, because the double slit experiment isn't about openings. It's about surfaces. It's not about 2 openings. It's not about 2 sources. It's about 4 sources. And that is such an obvious fact. The fact that people won't concede that obvious fact when it's, again, just obvious. Van Briesen talks about the math that works in all circumstances, and that's the math that counts the point sources, that counts the surfaces. Alright. So anyway, enough of the video, I think. Oh god, I have some miseries. Yeah. I went running and I did something to my shoulder. I mean, I have a bad rotator cuff. It's just miserably uncomfortable. And I got like a shin splint, and getting old sucks. That'll be the obvious conclusion. The obvious scientific conclusion is getting old sucks. Anyway, this has been a DraftScience video presentation. Until next time, and such, and whatever, so forth, blah, blah, blah. Who am I talking to? Is there any point in talking? Who knows?